So here is a model of a car. It is 7 1/4 inches long. Okay. The actual car is 14 1/2 feet long. This book is so wussy. They get such easy numbers in here. What is the scale? What is the scale? Okay. So scales have units, right? Both parts of the scale have units. So how do I get the scale of this model? It is so easy. Why is that?
Because they use half numbers.
Yeah, so 7 1/4 you recognize is half of 14 1/2. So that means every 1 inch of the model is 2 feet. That's it. Okay, that's it.
I would have done 2 feet.
1 inch to 2 feet. That's the scale.
I would have done 2 feet and 1/4.
Now, if these numbers are not friendly like that, and you can't do it in your head, you can always get the scale using a proportion, right? So if the numbers are not friendly, then write a proportion. Model over actual equals model over actual, okay? And if you want the scale, then you just make this a 1 on the top here. 1 inch is whatever the scale, to make the scale. More commonly, actually, and I'm surprised there weren't problems like this in the book, they'll say the scale of this model is, or this thing is 1 to 35. And then in real life, it's this big. How big is it on the model? Which there are some problems. You'll see some like that.
Those are fun.
Those, they typically don't have such friendly numbers in them, and you need to use a proportion, okay? But if you can do these in your head, I'm not going to make you write this proportion, okay, or solve it out, but realize that you can, okay? If the numbers are not ones you can figure out easily, then use a proportion, okay? And the other thing is, remember that scale is always model to actual, okay, or drawing to actual. All right, so that's the scale, 1 inch to 2 feet. What is the scale factor for this model? What is the scale factor? Stephanie? 1 to 24. And the way you get scale factor is that the units have to match, right? So 2 feet, you change to 24 inches, and that's how you get the scale. Again, that's easy numbers. So, yes, Sarah?
When are we going to get our quizzes back so we can see what we
You have them back. I mean, are the grades, you can't see the grades, I don't think, can you? But I'll pull up when we go to do the next independent practice work, I'll go on ClassKick and I'll let you see the grades. Then you can see what's right. And there's feedback on every problem that you got wrong.
How'd you get 124?
Okay, so it's 1 inch to 2 feet. Scale factor, these units have to be the same, right? So you have to change these feet to inches. So 2 feet is 24 inches. If this was difficult and you couldn't do that conversion of units very easily, you could always use dimensional analysis. You raised your hand, it was like your voice was coming out from behind you there. Okay. Don't call out answers there, big mistake.
Oh, that's how it feels. Yeah.
Okay.
That's going to be on recording.
Yeah. Oh, you're right. I'll send you that. So you can use. We'll make a little GIF out of it.
Please send us it.
Only some people will know what the joke is.
Just like, why is he talking about
Okay. Okay. All right. Next one, a map. Maps are scale drawings, right? So there's distances on the map that match up with actual real world distances. So the scale on this map, they say, is 1 inch is 20 miles. So what is the actual distance from Kansas City to St. Louis?
Oh, that's fine. I do not want to.
What?
You pronounce it like that?
No one says St. Louis. Well, that's not true. Some people do, but St. Louis. Most people say St. Louis.
No one ever taught me millimeters to centimeters, millimeters to meters.
There's a slide on that in the dimensional analysis. I think it was in the dimensional analysis or converting rates flip chart. It's in your book also.
But like I had to pull it up for my.
To remember with kilo and milli, which one is 1,000th and which one is 1,000. The only ones you need to know are milli, centi, kilo. Those are the only ones that people
Yeah,
use.
'cause it's just
Nobody
easy.
knows
Oh, yeah.
The other ones, they're not used very often. I mean, you could,
Very often.
well,
Like, what if
why did you ask that question? There's no millimeters on this problem anyway.
Miles!
Miles is not millimeters.
How many inches in a, I don't know.
How many inches are in a mile? I don't know what that is either. But I do know how to get there
The map
using
says 13.
dimensional analysis.
I didn't see that the map said 13. I just
It's
thought
okay.
whoever said running miles
Yeah.
10 inches.
Yeah.
It's
60.
Yes, big mistake, yes.
Okay.
Am I offending you? Do you want me to stop? Do I need to stop?
No.
No.
You guys don't get to answer. A wambulance?
260 miles.
Okay, how did you get that?
I multiplied 13 times 20.
Yeah, if it's 1 inch is 20 miles and it's 13 inches, very simple to just multiply 13 times 20. Yes, Maggie?
There's
She said it
63,360 inches in a mile.
Okay,
Uh,
how did you get that? Oh, you looked it up in Google.
I did that right.
Maggie, you're such a computer.
I would contend that just with a calculator, you ought to be able to figure out the scale factor of this.
How many feet are in a
How many
mile?
feet?
How many feet are in a mile?
5,200.
That's the one, if you can remember that number, it's the only big one like that that I told you might want to memorize. 5,280.
I was doing math. I was doing math with my dad, and he was like, "Okay, how many feet in a mile?" And I was like,
Yeah,
He's
okay.
like, 24.
So to find the scale factor here, I'm all about dimensional analysis on this one, okay? 1 inch is 20 miles. And what you want to do is get no units on the top and the bottom here. That'll give you a scale factor, right? So I got to cancel miles out. I'll go to feet, right? So 1 mile is 5,280 feet. And then I can go from feet to inches with a 12. The 12 inches goes on the bottom, the feet on the top, so that they all cancel out. This is a good review of dimensional analysis, right? And then so it's 1, 2, multi-dimension, how many dimensions you have. You can do this in 3 dimensions if you're going to do volume calculations. They can be pretty complicated, actually.
Whoa, that's so good.
1,267,200, that's what I got.
Yeah.
That's 20 times 5280 times 12. Okay, now, yeah, so that's the scale.
Wait, so
Scale factor, sorry.
you have to figure out, like, you have to be all fancy in the way you put it. Because, look, inches cancel out, everything cancels out.
Right,
Is that what you're trying to
it has to, right? That's what a scale factor is. It can't have any units,
Oh, okay.
right? The units have to be the same for the scale factor. Yes,
So could you just ignore the units? Like just not even put any units, like it would be a bad idea.
Well,
Like,
sometimes
could
it's
you just not put
you mean in your work or in the answer?
in the work?
I mean, I wouldn't do that. It's hard to keep track.
Yeah, that's what I mean. It would be a bad idea.
Right, it's a bad idea. I mean, sure, you can do it. It's just a bad idea.
Oh, that's fun.
that would be so